and we are now using the one of the possibilities. We download, we upload the data from the database. So we click load database, as on the right in this window you can see different options. EEG spectra computed for eyes open, eyes closed condition in 5 task condition. So because we compute a spectra for the task, so we select VCPT task and we just click OK. Yeah, we select patient, we click OK, and we got the difference wave. Each graph is the difference between the patient spectra and the normal spectra. So we compute spectra for the group of healthy subjects of the corresponding age, and we subtract the spectra from the spectra of this patient. So this is the results of this comparison. As you can see, in this patient there is increase of slow activity, and we can map this increase of slow activity. We just need to have the map window, and we can map this activity. So mostly this slow activity is at the left side of the frontally. And we can do this comparison by in absolute power, we can do it in amplitude, and we can do it in relative power. So to make comparison in relative power, just simply click in value this select this option, %P, and I usually normalize the spectra, so I am using normalization frequency band from 3 up to 30 Hertz. And in this normalization band you can see that this patient has excessive excessive activity at frequency band about 13 Hertz. So it's probably mu rhythm, which is generated over the sensory motor strip, and of quite high frequency band. Okay, so that's what we got from this analysis. Then we return back to EEG window. What we want to do, we want to compute event-related potential. So go to analysis. Click compute earpiece option, download parameters of processing from the database, click VCPT, we are doing VCPT task, and check whether these the parameters were already defined for subject response processing, and they were defined, digital 1. So click OK, and the program compute earpiece. Okay, the earpiece are connected. I usually prefer different colors that it's seen here. So go to setup and change the colors. Go to setup, graph formats, and select. Say we want to select the first the first category of trials to be green, and with the thick line. The next to be red, also with thick line. I prefer thick lines. The next would be blue, thick line, and the black, thick line. Okay. So that we got this. So that we have it, and this is earpiece computed for this subject. And let's select the second stimulus presentation and only go no go condition. So this is ERP for go no go condition. Now we correct the baseline from the second stimulus presentation. And here we see these ERPs for computed for go and no go condition. Green is go condition and red is no go condition. We can map the amplitude, the maximum of the potentials in go condition, in no go condition. As you can see, there is antherization of the no-go potential. I usually prefer not using these contours, so go to setup, montage style, and don't draw isopotential contours. Okay, then it's better, it looks better. And we can also compute the difference between go and no go condition, and we can compute can map the difference between go and no go condition. So everything looks quite okay. So we computed ERP that we can see ERP after the second stimulus presentation. So green is a go condition, red is no go, blue is different between go and no go condition. And then we can go to analysis and we can compare the ERPs with the database. And we can compute this. Okay, so we computed we compared ERPs with the database, so we go to analysis and we can see the results of comparison with the behavioral data. We open this window, which is results of averaging and subject response processing, and you see p-values of computing the deviation from normality. In this case, the p-value of deviation from normality in emission errors is 0.7, which is normal. P-value for reaction time is also normal. As you can see, the reaction time for this subject was 350 milliseconds, while in normal population just only 400 milliseconds, so he reacts faster than in norms. Variation of response is also smaller than in norms, so all parameters behavior look quite normal. And then we can compare ERPs for, say, for no-go condition in this patient, no-go condition in the normative database. On this window, green is the patient ERPs, red is normative data, and these are results of comparison. The normative data and the health and the subject data are superimposed on each other. Well, in this case, you can hardly say anything